Good morning, young ladies.
Good morning, teacher.
How are you?
Good morning, teacher. We are fine.
We are fine.
Can I get one of you leading us in an opening prayer? Then we will start our lesson. We are a bit late. Can I see someone leading us in an opening prayer? Mercy, can you go ahead?
Let's humble ourselves for a word of prayer. Our Heavenly Father, we'd like to thank you for this day. I'd like to thank you for the gift of life. I'd like to thank you that we've been able to come to this lesson. Oh Lord Father, we ask you that as we are going to attend this lesson, you may help us understand and prevent any distractions, any network disturbances. Oh Lord Jesus, we pray that we may contribute and be active in this lesson. In Jesus' name we have prayed. Amen.
Can you hear me?
Yes, teacher.
Yes, teacher.
Hello, girls. I don't get any response. Can you hear me?
Yes, teacher, we can hear.
Yes, we can.
Okay, so this morning, I hope your weekend was good and you are able to rest a bit and ready for the new week. We are going to continue with our work, looking at writing chemical equations. And of course, we closed last week when we were talking about elements that are diatomic. Can one of you remind me what does it mean when they say the element is diatomic? Can I get the definition from one of It has two atoms that make up a molecule. Thank you very much. And if you remember, when we're looking at the periodic table, we said elements in group 7, all of them are diatomic. Elements in group 7, all of them are diatomic. So can one of you remind me the elements in group 7?
Nothing.
Chlorine.
Chlorine. Chlorine. Can I get another one?
Jovia.
Can I get another one? Bromine. Bromine. And then there is also iodine. I hope you can see my board. So when I write these elements here, and they are reacting alone. For example, when someone says chlorine is reacting with sodium, that means when I'm writing chlorine, I should write it as Cl2 because it can only exist as a diatomic molecule. But when it comes to writing the formula of sodium chloride, then I use the valencies of that two. I hope we take note of the difference between writing that.
Please repeat that point.
I said that when they say sodium is reacting with chlorine, when I'm writing the equation, chlorine is supposed to be diatomic. So I write it as Cl2. So I have sodium here. It is reacting with chlorine. So I write Cl2. Then when it comes to writing the formula of the compound formed between the two, I'm expected to use the valencies. Remember, we said that when sodium reacts with chlorine, they form an ionic compound which is called sodium.
Teacher, we can't hear you.
Teacher, we can't hear you. Is my voice better now or not?
It is. Thank you.
So I said that when it comes to writing the formula of sodium chloride, the compound which is formed, then I must use the valencies of the two. So I work on the side. I have sodium, which is Na, chlorine, which is Cl. Can one of you remind me the valency of sodium?
One.
So I have one. What is the valency of chlorine?
One.
So I will interchange, have one here and then have one here. That means the formula of sodium chloride is NaCl using valencies. So after I have got the formula, I write it at the other end of the arrow where we said we put the product.
We can't hear you.
Now I said that when I'm writing, can you hear me now?
Yes.
So I said that when I am writing the formula of the compound, we use their valencies. I hope you can see the equation that I have put on the chalkboard. I have sodium plus chlorine, which is diatomic, to give me sodium chloride, which I have written as my product there. Can we all see that?
Yes, teacher.
So I hope that explains the bit where we're saying if you're dealing with an element that is diatomic, you write it with a 2, as long as it is alone. But when it is combining with another substance, you now use the valence to write the formula of the compound formed. Apart from the group 7 elements, even oxygen is diatomic, nitrogen is also diatomic. So they're about those elements, not very many, and you need to know them. So every time you have oxygen gas reacting, you have to write it as O2. But when it forms an oxide, then you use the valence to write the formula of the oxide. I don't know if I have any questions, because now I'm going to go through the equations that we have. Those are the examples. By the way, I need to remind you that our notes are like this. They don't have the answers. I don't know if you have already printed them out. And as we go through each number, you should be writing them in your notes. Have we all printed the notes?
Teacher, are we supposed to print all right?
if you writing, we must write them in our books, but before you, if you have not finished to write, then you should have a copy that is printed where you're putting in the answers. Is that clear?
Yes, teacher.
Because this is what you'll print out, so it must have the answers because we are answering the questions as we go along. Chisache, do you have a question?
No, sorry, teacher.
Okay, so we are now looking at writing the chemical equation from those word equations that we have. We looked at equation number 1, which was hydrogen reacting with oxygen to give us water. Can someone remind me, how do we write that equation? One person? Or hydrogen plus oxygen to give us water.
H2O.
H2 is not an equation. I want us to write about
H2 plus O2, you get H2O.
hydrogen. So I hope all of us have that in our books.
Excuse me, teacher.
Yes, please.
Teacher, I didn't understand the first point that you are giving, so I don't understand how H2 plus O2 gives H2O without the O having a 2.
Without the O having a 2. Thank you. I'll go through that. So we say we have hydrogen, which is diatomic, so we write it as H2. Oxygen, which is also diatomic, we write it O2, and the product is water. But I think when you're writing water, now you have to use the valencies of hydrogen and the valency of oxygen.
Sure, we can't hear you well.
You're not so clear. Sorry, not clear.
I don't know why. Can you hear me now?
Yes.
Yes. Okay, I said that we have to write the formula of water. So I said that to write the formula of water, we need the valencies of the 2. What is the valency of hydrogen? Can one of you remind me?
1.
1.
1. 1.
One there. What about the valency of oxygen?
2.
2.
So the next step is to interchange the valencies. So that means the formula of water is H2O using the valencies. I don't know if the person asked the question, you're now okay, why we are writing H2 and we are not putting that 2 there. Is that fine?
Yes.
I'm now going to look at question 2. I hope all of us can read question 2. Can one of you read for me question 2 so we go through it together? Yes, Angel?
Teacher, I wanted to ask a question first.
Okay.
Teacher, for the equation we've just done for water, how come it's H2 plus O2, but then in the for the water, we have only oxygen having 2 and not hydrogen, and yet in the formulas it had 2.
Now, Angel, I said that when we are writing the formula of water, we use the valency of oxygen and the valency of hydrogen. We have just said that hydrogen has a valency of 1 and oxygen has a valency of 2. So when we interchange the valencies, the 2 goes to hydrogen, so it becomes H2O. Is that okay, Angel?
Yes, teacher. I didn't get that bit. I had thought we use the, I don't know what you had written, the H2 and O2, but it's okay. Thank you.
So you're reading
And
for me question.
Teacher, before, does that mean that for all the equations, we are going to have to use valencies or only specific ones?
When we are writing the formula of a compound, we use the valencies.
Oh, okay, teacher. So the question,
Mhm.
calcium plus oxygen gives calcium oxide.
So can you give me the symbol for calcium?
Ca.
Thank you. Can I get another person giving me the formula for oxygen?
O2.
Okay, so we are writing the formula of calcium, which is Ca, and we have said once oxygen is alone, remember it is diatomic. So we are putting O2.
Excuse me, teacher.
Yes, please.
Teacher, I'm sorry to take you back, but which notes are these?
These notes are about equations and chemical formula. We sent them on Google Classroom.
Teacher, how comes I can't see them?
Teacher, these notes are different. We don't
Teacher,
have
they're
them.
I'm not there.
These
They're not
notes
on
are not
Google
there.
Classroom.
No, they are there,
Yes,
but
they are
they're
not there.
incomplete.
This one is a different one. Please stop on page 7. I was even confused.
Hard.
Okay, can we be attentive? We are going to update the Google Classroom if you're sure they are not there. We can follow through. You can write somewhere on your paper such that when you get these notes, you can update your notes as well. Is that okay?
Yes, teacher. Yes, thank you, teacher.
Now
Save my-
we are writing the formula for calcium oxide. I need one of you to remind me what is the valency for calcium.
2.
Valency for oxygen.
2.
I'll do it down here, then I'll finally put my formula where it should be. Can one of you tell me what is going to happen to the twos? Because both of them are similar valency. So they will
get cancelled.
Write them.
out. And remember, we don't write a valency of 1.
1.
So what is the formula for calcium oxide?
CaO.
CaO.
I hope that is okay with all of us now.
Excuse me,
Teacher.
Yes.
Yes, someone has a question for me.
just to confirm, you say that if an element is diatomic, while we are writing on the left-hand side, we write the symbol and we put a 2 at the bottom because it's diatomic. But for the product, we don't add the 2. We use the valences.
Yes, I said we use valences when it comes to writing the formula of the product formed between the 2. Thank you. That's right.
Excuse me, teacher.
Yes, please.
So does when oxygen reacts with something else, does it always become an oxide?
Someone is reading for me that equation. Can we have someone reading?
Carbon plus oxygen is equal to carbon dioxide.
Sylvia, can you give me the formula, the symbol for carbon? Anyone has a question about number 3? We need to be moving together. It can be a little bit challenging, but also easy at the same time. So can we move together? Someone has a question for me for Roman 3?
Excuse me, teacher. Okay. Excuse me, teacher.
Yes, please.
Can you say carbon plus peroxide? Does it give you CO2 also?
Now remember, we said there are elements that can never react with a peroxide. So we cannot have carbon reacting with a peroxide to form a compound. That compound does not exist.
Okay, thank you, teacher.
You're welcome. Someone giving me a question, another one. I think there were some other people putting up their hands.
Yes, teacher. So in this equation here, we don't use the valences for finding the formula of the product formed.
We use the valences, but I didn't want us to go through that because we said that if an oxide is written as carbon dioxide, it means you have carbon and 2 oxygen atoms. But we can be able to write the formula using the valence. Can you tell me the valency of carbon, young lady?
It's 4.
Go through. What is the valency of oxygen?
2.
2.
When we interchange, what do I do with those valencies, young lady?
You divide them by common factor, which is 2.
By 2, I get 1 and then 2. Remember, I don't write the valency of 2. So that is why our formula is of 2. They use the valence to come up with that formula. Is that okay?
Yes, teacher.
Any other question? Now, if you are in at the start, we have already done number 4. Can someone remind me, how do we write that equation for number 4?
is Na plus Cl2 is equal to Na HCl.
So we said here, sodium is Na, but chlorine is diatomic. And because it is diatomic, we write it as Cl2. Now, I also explained why the formula is NaCl. Can I get one of you explaining to me why we got the formula as NaCl?
Because the value.
Because the valency of sodium is 1.
Of sodium and the
And
valency of chlorine is 1.
chlorine.
So
The
we said
valency of
sodium. Okay, thank you. We said sodium has a valency of 1. Chlorine also has a valency of 1. So when we are writing the formula of sodium chloride, we use those two valencies. That is why it is NaCl. Angel, do you have a question?
Teacher, I forgot my hand.
Johanna, do you have a question?
Yes, teacher, so does that mean that chlorine and chloride are the same things? Only that the other one is it negatively charged? Positively,
Exactly.
sorry.
Yes, when I talk of chlorine and then chloride, chlorine has not yet gained an electron. But when chlorine gains an electron, it becomes a chloride.
So their valencies are supposed to be the same.
Yes, please. Is that okay with you?
Yes, thank you.
Someone reading for me number 5.
Magnesium plus chloride is equal to magnesium chloride.
Someone giving me the symbol for magnesium?
Mg.
What about chlorine?
Cl.
That word should be
Cl.
chlorine. Though we have written a chloride there, you'll make a correction, it is chlorine. Thank you. So we have Mg. Remember, this G is a capital letter. Sorry, the M is a capital letter. Okay, so we get magnesium plus chlorine, which is Cl2, giving us magnesium chloride. I need someone to take me through how we write the formula for magnesium chloride.
MgCl2.
You mind explaining to me how you got that?
Using the valencies. The valency of magnesium is 2, and then the one for chlorine is 1. So I interchange the valencies, and then I got MgCl2.
Thank you very much. I hope all of us are following through. Is that fine for all of us?
Yes.
Can I get any questions as we go to number 6? Any questions as we proceed to number 6?
Teacher?
Yes, please.
You said we are using chlorine and not chloride. So is chlorine a diatomic molecule as well, atom as well?
Yes, I said number 4, we should change that word. Instead of calling it chloride, it is chlorine. So it should read magnesium plus chlorine to give magnesium chloride.
So teacher, how do you know that they are atomic atoms?
My friend, that is where I started from. I said group 7 elements, all of them are diatomic. If you remember when we looked at periodic table. So if you remember any element in group 7, that element is diatomic. That is fluorine, chlorine, iodine, and then bromine. Then on top of those two, the other common ones that are diatomic are oxygen and nitrogen. There are not so many, you should be able to get them.
Okay, teacher, I had come in late, so, but thank you.
We have a table in the notes, so when you get these notes, you should be able to see those elements which are diatomic.
Okay, thank you, teacher.
Welcome. Someone reading for me number 6.
Copper 2 oxide plus hydrogen.
Then is equal to copper plus water.
Now, many of the equations that we are using here, you looked at them sometime in your notes before. So you need to refer to your notes a bit and be able to remember some of these things. So we have copper 2 oxide. Now that one is a compound. Is it okay? And this is where we looked at hydrogen as a reducing agent, if you remember. We said hydrogen reduces oxides of metals below it to the respective metals. So this is one of the equations that we wrote before. So now we should be able to practice how to write the chemical equation. So someone, can you tell me how do we write the formula of copper 2 oxide?
CuO.
CuO. I'm getting Jovia many times. Thank you for participating, but I need to know if all of us are following.
Yes, we are.
I don't understand.
Yes, teacher.
Oxide with hydrogen to form copper and water. Could you please re-explain that?
I said that this is one of the properties of hydrogen that we looked at when we were looking at hydrogen gas. And we said that hydrogen is a reducing agent. Reducing agent is supposed to be a substance that removes oxygen from another substance. So in this case, copper 2 oxide is converted to copper when hydrogen removes oxygen from it. Is that okay, young lady?
Yes, thank you.
So can someone, we said CO, okay, we can go through this together. When they say copper 2, we said that means copper is using a valency of 2. Remember, copper has more than one valence. So they have specified it is copper 2, meaning it is using a valency of 2. What's the valency of oxygen, young ladies?
2.
2.
So how do we deal with those two valencies? I hope you note that they are similar, isn't it?
Yes.
Yes.
How do we deal with them?
We get rid of them.
How do we do that?
Cancel them out.
Cancel by
Reduce
2.
them to your simplest ratio. And that's
So
1. So
this one explains to us why I'm going to write the formula of copper 2 oxide as CO only, without anything else. That is CO. And I'm moving to hydrogen. How do we write the formula for hydrogen?
we include a
H2O. H2.
So hydrogen is also diatomic. If you remember, we said we can also put it in group 7, and we have just said all the elements in group 7 are diatomic. So hydrogen is also diatomic. What is the symbol for copper?
Cu.
Cu.
What is the formula for water?
H2O.
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 So I hope I don't have to explain now why it is H2O. Do I have to go through that again?
No.
No.
So that is how our equation would look like. We have copper 2 oxide, which is CuO, reacting with hydrogen, and the products are copper and then water. Can I get any questions?
Excuse me, teacher.
Yes, please.
Is this also related to like the reactivity series? Since hydrogen comes before copper, so it like takes the oxygen. Is it related?
Yes, it is. It is like a displacement reaction. We said hydrogen can only reduce the oxides of metals below it in the reactivity series, of course, apart from lead, which is also very close to it. So in this case, hydrogen removes the oxygen, and then the oxygen becomes a metal. Sorry, the oxygen combines with hydrogen to give us water, while copper remains as a metal. Is that okay?
Yes. Thank you.
If I have any questions from you young ladies, before I move to the physical states, any questions? Now, I will refer you to the book that you have. That book which has revision questions for S1 and S2. There are so many equations there, and you need to try them. Convert the word equations to chemical equations. I don't seem to have any questions. Can I move on now?
Yes.
Okay, we are looking at the physical states. Can one of you remind me, what are the different states of matter? The different states of matter?
Liquid state, gaseous state, solid state.
Solid state, liquid state,
Thank you
and
very much.
gaseous state.
Now, when we are writing equations, we are supposed to show, is this element solid? Is it gas? Is it liquid? We shall also have another state that we call aqueous. So those are the physical states. I know some of you that have looked at equations, you must have seen sometimes writing small letters. For example, here, they put something like that, copper 2 oxide, then put a small s and put it in brackets. Now those figures are supposed to represent the physical state of the substance. Is it reacting as a solid? Then you put a small s. But we put it in brackets close to that compound that we've just written. Is it a liquid? We use small l. Is it a gas? We use small g. Someone reminding me, what is an aqueous solution?
Thank you.
What is an aqueous solution?
Slightly
Dissolved
solid water.
Aqueous solution is one that
It's
dissolves.
like
Contains water.
Slightly dissolves in water.
Molten.
What is dissolving in water? Okay,
What do they
thank
mean
you.
by slightly?
It is a solution obtained when water is the solvent. For example, when you are at home and you get your table salt and you dissolve it in water, that solution which you have is what we call an aqueous solution. I hope that is okay for all of us. when you get salt, you put it in water and it dissolves. So the outcome is a solution. Because you have used water as the solvent, we call it an aqueous solution. So that is also another state that we use. For aqueous, we use small a and then small b. Also brackets. So do I have any questions as far as the states are concerned?
Excuse me, teacher. Is the result of, okay, can an aqueous combine with another state? For example, solid.
For example, solid.
Yeah, like will the result still be aqueous if an aqueous solution combines with? Yeah.
I don't seem to get your question, but it depends. For example,
I actually don't have one.
You don't have a question?
No, I was just asking. I didn't have one in mind.
Now, if I have a solid, for example, a metal reacting with an acid, in most cases, acids are aqueous, or they are in aqueous state because they are dilute, meaning they have been dissolved in water. So that means the metal is solid, but the acid is aqueous. So I write solid for the metal, then aqueous for the acid. Is that okay?
I think.
Repeat.
Petra, do you have a question?
Please repeat that.
How exactly are we supposed to know if the solution is aqueous or if it's liquid or if it's solid, or we'll just like learn them along the way and like memorize it?
Petra, that is a very good question. We usually learn these things along the way, but I should also state, for example, we know all metals are in which state, Petra? All metals are very good. Solid. So do I have to tell you that when you're reacting magnesium, you need to put solid? So some of we are that way. No one will tell you that now this is solid. This, as you learn, you should be able to know that this is solid, gas. Now the other thing, when we looked at the group 7 elements, we gave them gas. Can one of you remind me what is the state of chlorine?
Gas.
Gas. Then chlorine.
It's a gas.
It is a gas. So just like Petra asked, how shall we know? We usually know from the properties that we keep studying as we study chemistry. We said all metals are solid, so that means when you're writing an equation and it has a metal, you need to put a space. If you're dealing with gases, we also have many elements that we know are gas. Can you give me examples of the gases?
Hydrogen. Oxygen.
Oxygen, good. Another one?
Nitrogen.
Nitrogen, another one? So that means when you come across those elements, you will put the state as gas. I hope that is okay. Of course, for me now, I wanted to introduce the bit that when we are writing an equation, we are supposed to include a physical state. Of course, for the start, some of the states we may not know, but as we go on, we get to learn the different elements and compounds with their states. What is the state for water, for example? Can someone tell me?
Liquid.
State.
So water can be a liquid, but when I talk of steam, what is the state?
Gaseous.
So from the elements that we have so far studied under compounds, we should be able to know some of their states. But if they are new, of course, as we go on, we also learn to write their state matter. So in our notes, we have some examples there. We have magnesium reacting with chlorine to give us magnesium chloride. Mr. Juna, you need to help me change here. Magnesium chloride is a solid. Okay, so I'll try to go through some of the equations that we have already looked at and show you how we put them. Just a few examples. We said hydrogen is a gas, isn't it?
Yes.
So I will write here, usually the state should be smaller, but almost on the same line as the symbol. I put the small g and put it in brackets. It is reacting with oxygen. Which state is oxygen?
Gas.
Gas.
We said the product there is water. In which state is water?
Liquid.
So that is how my equation will appear with the states of matter indicated. That hydrogen is a gas, oxygen is a liquid, sorry, oxygen is a gas, giving me water, which is a liquid. Any questions, young lady?
Yes, teacher.
Can you go ahead?
When you're writing the physical state of the element, do you write it on the same line as the element, or you can write it like below the element?
It should be on the same line. Do you see how the equations on the screen appear? It should be on the same line, but smaller and in brackets.
Okay, thank you.
Can one of you tell me what state is magnesium? I hope you remember magnesium is a metal. So in which state is magnesium?
Solid.
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 Which state is chlorine? Remember, it is group 7.
Gas.
Chlorine is also a gas. Now we should note also that in most cases, when metals react with gases, the product is a solid. I hope we noted that when metals react with gases, the product is solid. When, for example, metals react with oxygen to give us oxides, all the metallic oxides are solid. I hope we noted that. I said there are some of those general things, how we'll be getting the state.
Like magnesium oxide.
Yes, magnesium oxide is solid, calcium oxide is solid, copper 2 oxide is solid. So as long as the metal has reacted with a gas, the product is usually solid. Now, I said, young ladies, you have a book that has many equations in it. If you do yourself a disservice by not doing those equations, it will be very bad. You need to do a lot of them such that you get better. Do I have any questions? Because I think our time is up. Any questions? So if we don't have questions, our lesson will end there because the next step will be looking at balancing equations, and we can't start today to balance the equations. So today we have looked at converting a word equation into a chemical formula. You need to practice that. And we have also looked at introducing the state symbols, that if a substance is reacting or forming the product, I should be able to say this substance is solid, this substance is liquid, this substance is this. If you don't have any questions, I want to wish you a good day. You can rest and then prepare to start your next lesson.
Thank you, teacher.
Thank you, teacher. Good day too.
Teacher.